All right, we're going to get started on day 14 notes. It is solving exponential and logarithmic functions. There is something on these notes for everybody, even if you feel like you struggle with solving. First, we're going to start with some review of stuff. So you guys help me out filling out the blanks. If you have log with no base, that represents what type of logarithm? Common, very good. A common log. And what is the base when the base isn't shown? 10. Good job. What about ln? What does ln, what type of log is that? Natural log. And a natural log has a base of what? E. Moving on, this is the first part of graphing. You will have questions like this on your test. And the solution is when the graph crosses the x-axis. The solution is when the graph crosses the x-axis. The directions say to draw the asymptote and find the solution for an exponential graph. So for an exponential graph, you will have a horizontal asymptote and it's going to go right underneath wherever the data is. Sorry, wherever the curve is. So for this one, it's going to go right there. That's right underneath where the curve is. I'm going to go ahead, since I got my red pen, I'm going to go ahead and sketch on the asymptote for this graph. It's going to be at 0. Okay, so that is drawing the asymptote. And the next part is finding the solution. So the solution is where the graph crosses the x-axis. So on the first graph, do you see where the graph crosses the x-axis? Where does this graph cross the x-axis? So this is the x-axis, right there at 2. And that is your answer. You could put it in a little set if you wanted to. For the next graph, where does this graph cross the x-axis? So keep in mind, it does not touch the asymptote. It will stay above the asymptote. So where do you think that one is going to cross the x-axis? I feel like I heard somebody say it. Where is it going to cross? It has to stay above that asymptote. Never. So if it never crosses, what is the solution? No solution. There isn't one, and that's okay. You can have no solution. If it doesn't cross, there's no solution. Don't overthink it. You got to cross to have a solution. The next two questions are logarithmic questions, so these graphs are different. Exponential graphs have a horizontal asymptote, and exponential will have a vertical asymptote. So for these, I'm going to first sketch on my asymptotes. Again, I got to put my asymptote. And for these, they will be a vertical line. And I'm going to sketch on my vertical line for the last one. But the answer is still the same. The answer is still, where does the graph cross the x-axis? So for the first one, where does this graph cross the x-axis? For this graph, where does it cross the x-axis? At 3. Don't overthink these. These are easy questions. I could put it in a set. What about this one? Where does this graph cross the x-axis? At 1. Don't overthink it. Okay, so finding the solution from a graph, easy peasy, easy stuff. Finding the solution from a graph, easy stuff. Please make sure on your homework that you show me asymptotes and you put the answer. Moving on, the next thing that we're going to talk about is the property of equality for exponentials. And this is a property that we've already been doing. This is the property of equality. The property of equality for exponentials. And this is very mathy, but it says that if b, which is the base, is bigger than 0 and it's not equal to 1, if you have this situation here, when the bases are equal, what do we do? When the bases are equal, what do we do? Y'all remember we've been solving these, that we try and get the bases the same on both sides, and what do we do with them? Mark them out, and we set the exponents equal. So this works if and only if the exponents are equal. So x has to equal y. And this is like a situation that we've been doing. So if we had this problem right here, what would we do? We would mark out what? And then what would equal what? Yes. So we would mark out the 3 and then x equals 5. And that's what we will try and do. We will try and make the bases equal. That's the property of equality. We will try and make the bases equal so that we can set the exponents equal and solve. So for the first question, are the bases equal? For the first question, are the bases equal? Yes, so let's mark them out. And let's set the exponents equal. This is only one step more than what we've been doing. Now we just have an equation to solve. So for this one, I'm going to first add 5. And then what's my last step? Divide by 3. What's 15 divided by 3? Very good. That is my answer. For the next question, I have a base of 3 and a base of 9. Okay, I can't turn 3 into a base of 9, but I can turn 9 into a base of 3. 9 is the same thing as 3 to what power? 2, but it's going to be a 2 times 4 power. 2 times 4 is 8, so it's 3 to the 8th power. And as soon as my bases are equal, well, property of equality says that I can mark them out and set the exponents equal. And I'm done. For the last problem in this section, I have a base of 2 and a base of 4. They're not equal, but we can easily make them equal. I can't turn 2 into a 4, but I can turn 4 into a base of 2. 4 is the same thing as 2 to what power? Yes. Hello? Yes. Well, we're doing notes right now. All right, thank you. Bye. All right, so I have 2 to the 2x power is equal to 2 to the x plus 7. Now I have bases that are equal, so I'm going to set my exponents equal and solve for x. So I have x plus 7 is equal to 2x. This is our first problem that has x's on both sides. So my method of solving these problems is that I look for which x is bigger. And so right now I have a 1x and a 2x. Which one of those is bigger? The 2. So the bigger one is like a magnet. It's going to suck the other one over. So I leave the bigger one where it is and I move the other. So I'm going to bring that over and subtract 1x. 2 minus 1 is 1x, or just x. I have for you a fix on the homework. Please change question number 3. Right here it says -4, I think. Change it to a -6. It will make that problem a little bit easier to solve. So please make this change on the homework. Change the 6 the 4, change it to a 6. Is anybody still copying? Can somebody that's not taking notes let Aslan in, please? All right, continuing on to the back, I want to make sure that we get done with the notes with enough time that you can work on your homework. On the back, we're going to learn about the property of equality for logarithms. The property of equality for logarithms. So the first part of this is very similar to what we did on the front. If you have logs with the same base, same idea. If you have logs with the same base, you can mark out the logs and set the stuff equal to each other. So for this problem, if I have log base 5 of x is equal to log base 5 of 8, then what equals what? X equals 8. Very good. If the log base is equal on both sides, if it's the same on both sides, you set the stuff equal to the stuff. So x is equal to 8. And that's what we're going to do here. For the first problem, I have log base 5 of 30 is equal to log base 5 of 3x. The base is the same for the logs, so I can mark them out and set the stuff equal. 30 equals 3x. What do I do? Divide. Very good. Divide by 3. And so x is equal to what? 10. I'm glad that I have a few of you guys paying attention. For the next problem, do I have 2 logs with the same base? Okay, and they're set equal to each other. So anytime you've got a log and a log on both sides, you can mark them out as long as they have the same base. And this one does. What is the base? It's not shown, but what is that base? 10. If we needed to know it, it's a 10, and it's called a what kind of log? Common log. Okay, you're going to have that question on your test. We got to know it. So now I set all the stuff equal. 2x plus 8 is equal to x plus 5. All right, this is another situation where we have x's on both sides. Which one's bigger, 2 or 1? 2. So let's bring the 1 over because the bigger number's like a magnet. So we'll bring that over and subtract 1x. And since we're bringing all of the x's to the left side, let's bring the numbers or the constants to the right side. So I'm going to subtract 8 on the right side. So I have 2 minus 1, which is just 1x, equals. And then what is 5 minus 8? -3. And that is my answer. One thing that's kind of nice with working with the logs is that the base is already the same. Like you can't do anything if the bases aren't the same. So it's a little different than exponentials where you have to make the bases the same. For logs, they are the same and you can do something with them, or they're not the same and you can't. For our last problem in this section, this is ln. What kind of log is that? Natural log, and what's the base for natural log? E. These are equal, so we can mark them off and set the stuff equal. So I get x squared is equal to x plus 20. Anytime that you end up with x squared, you're going to factor it. And this has been a long time since we factored. We've slept a lot since we factored. To factor, you want the x squared on one side and you want it to be positive. So right now, is my x squared positive? Yeah, it's positive x squared. Leave it. Leave it and move everything else to that side. You need your quadratic, and we're going to factor it. You need it to be equal to 0. So I'm going to bring over and subtract 1x and subtract 20. And it will be left equal to 0. Again, I know that it's been a long time since you factored, so this might be the time in your notes that you actually tune in to get a refresher on factoring. All the factoring problems that I will have you do will have a leading coefficient of 1. That means you can fast factor. So to fast factor, we're going to have 2 parentheses, and they're both going to have an x in it. And all we're thinking of is 2 numbers that can multiply to give us 20, that could add to give us 1. It is going to be a negative 20, but before you even get there, you can just think of you can think of it even being positive. What are 2 numbers that could multiply to make 20 that could put together to make 1? So think of things that multiply to make 20. What 2 things could multiply to make 20? 5 and 4 would work. If you put them in here, 4 and 5, which one of these numbers is bigger? 5. So the 5 has to have the same sign as the middle one. So the middle one is negative. The 5 has to be negative. And if I have negative 5, would I add or subtract to make negative 1? If I subtract, I get negative 9. So I'd have to add. Also, I've got to double check that when I multiply them, the only way that I can make a negative is if only one of them is negative. So the 5 will be negative. But now I've factored. What does x actually equal? Remember when we did this, and it's always the opposite of the number here, or the sign here. So it would be negative 4 and positive 5. Once you factor, x is equal to the opposite. So it would be negative 4 and positive 5. And it's because if you actually set both of these equal to 0, that's what you would get if you solved. Down here, it tells you that you can't take the log of a what kind of number. We already know this. We've done it. Can't take the log of a what kind of number? No? Negative. Most of the time when you're solving these, you're going to get numbers and they're going to work out and they're going to be just fine. But every once in a while, it works out that when you plug in your value back into the log, it would create a negative inside those parentheses, and you can't have that. So I'm going to show you what you got to double check for. When you get x is equal to a positive number, usually that's not an issue. If we plugged 10 in, like there's not even an x here to plug it in, so that doesn't matter. But if you plug in 10 here, you get 30. Is 30 a positive number? Yeah, so that's fine. It doesn't matter. Here, this one is a negative number, so you want to just double check that if you were to plug it in, does it create a negative in the parentheses? For example, if you plug in negative 3 here, what's 5 minus 3? What's 5 minus 3? Is that positive? Yeah. So did that create a problem? No, that's fine. Here, if I plugged it in on this side, 2 times -3 would be -6. What's 8 minus 6? Is that a negative number? Then it's not an issue. For these, and remember, if we solved correctly, what this equals is the same as what this equals. So if you plug it in over here, if you plugged in -4, well, what's a negative times a negative? A positive. So is that an issue? No. Okay. So we just have to double check. Sometimes it is an issue. Most of the time it's not. And we only have to check because you cannot take the log of a negative number. Moving on with our notes. If two logs with the same base are on the same side, we're going to condense them. So two logs with the same base are on the same side, you can condense them. And what I mean by that is what you've already learned. So we're going to take something that we already learned and we're going to apply it with these new solving problems. So what I notice is that for our first example, what we need to be able to use the property of equality is that we need log equals log and nothing else. You can't add or subtract anything. It has to be log equals log. And the problem here is that you've got log plus log. But that's okay because we know what to do. If I want to condense this, if I am adding, what do I do if I put it together? What do I do with the stuff inside when you're adding logs? Multiply. So that's what we're going to do. We're going to say that log base 7 is equal to 4 times 8. Well, what is 4 times 8? They're both numbers, so we could multiply it. Close. What's 4 times 8? Y'all have the ability to use a calculator. Oh, in my mind, I was thinking, no, y'all are so correct. I was thinking 4 times 7. And I was thinking, why is nobody getting the right answer? It's 28. It's so obvious. Y'all are correct. It's 32. It's been 32 your whole life. It's correct. Y'all were correct. Sorry. That was me. That was me. 4 times 8 is 32. Good job, y'all. As soon as we get our logs with the same base and they're on either side of the equal sign, what can we do? What can we do from here? Cancel out the logs because they're the same and let's set the stuff equal. And I am done. I'm sorry I made you guys second guess your whole math career. Y'all were so correct. My bad. The next problem, we're going to use the similar technique that we've got two logs on one side. So let's put them together. Let's condense them. This time I'm subtracting. And what do I have to do if logs are subtracting? Divide. I heard it. Divide. So I will have log base 4 of 16 divided by x is equal to log base 4 of 8. And now that I have two logs that are equal, I can mark them out and set the stuff equal. Do not freak out because there is a fraction. Because this problem is actually pretty easy. What we're going to do to solve this one, the x and the 8 can switch places because we need to divide by 8, but we also need to know what x equals and it's dividing. So the inverse of divide is multiply. So it would come over here. They actually can just switch places. So I get 16 divided by 8 is equal to x. What is 16 divided by 8? 2. Very good. This skill right here where you have to condense something before you can solve, when I did the homework, I noticed that I didn't see any actually on the homework. Let me double check that you have some on your review because you will have some on your test. Today's the last day of stuff we're learning before the test. Yes, like question number 25 and 28. Okay, on your review that you should have started, questions 25 and 28, those are like these problems. There isn't any on your homework, but there are definitely some on the review. There are some on your tests. So question 25 and 28, you have to condense those before you can solve. Same with question 31. 25, 28, 31, you have to condense all of those before you can solve. One last thing to talk about. When you only have one log or exponential, when you only have one. So when I look here, is this the property of equality? Do I have a log on both sides? No, I don't have a log on both sides. What about here? Do I have a base on both sides holding something up? No, I don't. So when you only have either a log on one side or an exponential on one side, the way that you have to solve it is by rewriting. And we've learned how to do that as well. You have to rewrite to solve. So when I say rewrite, it's doing this thing, like that swirly thing. You have to rewrite. Oftentimes these problems, not every time, but a lot of times these problems, you might get decimals. Okay, for these problems, you might get a decimal. At this time, if you do not have a calculator, go grab one because you might need it. You will need it. Okay, at this time, if you don't have a graphing calculator, go grab one. When the pass gets back. Maybe check and make sure it turns on before you walk all the way back to your seat. So our first step is going to be to rewrite. So when you have a log, you'll rewrite it like that. So that turns into 2 to the 5th power is equal to x squared minus 4x. This is when we're going to use our handy dandy chart. When you look on your lime green chart, what is 2 to the 5th power? 32. All right, so I've got 32 is equal to x squared minus 4x. And I said that anytime that you have an x squared problem, you have to solve them like a quadratic in factor. So you're going to get better at this. So to solve it like a quadratic, I got to get everything on one side and solve by factoring. For this one, is the x squared positive? Is the x squared positive? Yeah, so leave it. Otherwise, we would move it, but leave it. The x squared is what's important. If it's positive, move everything else. So we've got 0 is equal to x squared minus 4x minus 32. To factor this one, I'm going to get 2 sets of parentheses. We're going to have x and x. What are some things that could multiply to make 32 that could be put together to make 4? What things could we multiply to make 32? Y'all already know this one. 8 and what? 8 and 4. So we could use those numbers. 4 and 8 will multiply to make 32. Which one of these is bigger? 8. So it has to be the same sign as this one. It has to be a negative 8. So if I have negative 8, would I add or subtract to make negative 4? I'd have to add. I'd have to get more positive. Also, to make a negative here, By multiplying, only one of these can be positive. Now that I'm factored, what does x actually equal? We talked about this, that they're the opposites. So what does x equal? -4 and +8. All right, let's check our -1. Let's check the -1. If I plug the -1 back into the problem, what is the negative times a negative is a positive. So anytime you square it, it will be a positive number. 4 times 4 is 16. So that would be the first number would be 16. And then it's going to be 16 minus what's -4 times -4 again? Yeah, it is. So -4 times -4, so it would be plus 16. Negative times a negative would be a positive. And we get 16 times, or 16 plus 16. Is that going to be a positive number? Yeah, so that this negative answer, it doesn't matter. Sometimes you have to mark it off because it doesn't work. It doesn't, it's fine. It's good. It works. So you have to check to make sure anytime you get x is equal to a negative number, and this is only for logs. When you solve and it's exponential, it doesn't matter. For this one, I don't have I don't have base equals base, and I can't turn 2 into e. So for this problem, I have to rewrite it. And I know that this is going to be a natural log because it has a base of e. And I know that using the little swirly thing, it's going to be e. And then I'm going to have, after the equal sign, I'm going to have -2x. So e to the -2x power is equal to 2. So 2 goes right here. This is a problem that we're going to get a decimal answer, and I'm going to show you how to do this. To do this, what you're going to type into your calculator is this, ln of 2. To do that, you're going to find the ln button on the calculator. So looking down the left-hand side, so you're going to look down this left-hand side, you're going to find, under log, you're going to find ln. And when you press the ln button, you're going to put 2 and press enter. When you do that, you get an ugly decimal. Did y'all type it in? Did you get the ugly decimal? So down the left-hand side of your calculator, down the left-hand side, underneath the blue button, you're going to follow down until you see LN. You're going to press LN, and when you press LN, you're going to do LN of 2 and press enter. You're going to get a decimal. So we could round that decimal. We could call it 0.69 is fine. Okay, I got 0.69. Is that what y'all got? So we want what x equals. So we're almost there. What do I need to do to get x by itself? Divide by -2. So good thing is that you already have this number pulled up on your screen. So all you have to do, you don't have to retype it or anything. All you have to do is when you have that number, the last thing you typed in, you just press divide by, and it says answer divided by -2, enter. And then you get your answer. What do you get? It's going to be negative point. If we want to round it to 2 decimals, that would round to 0.35. And that's fine. So sometimes you will get decimal answers, and that's okay. So now I'm giving you time to work on your assignment. You've got 30 minutes, and I have worked them all. So please check your work with me, because there's some problems that you might need help with, like typing in the calculator the log with a base. You might need